Hi guys, welcome back to my channel. For those of you who saw the first episode, thank you very much. Uh, if you followed, I hope whatever it is you did worked on your system, and hope you didn't have any issues. So far so good. I didn't get any questions, so I want to assume that whatever it is you tried, it worked. So now let's take this a little bit further than where we were last week. Or 2 weeks ago. So let me start by showing what we currently have done, right? So right now, you can see that we still have our modules folder, and inside our modules folders, we have the operators defined, okay? So the operators defined here, and in the calculators file, we have the actual operation running, where we all call all the operators functions into the action variable, and also define addition, subtraction, multiplication, remainders, division, square roots, and cube roots. Right, we define all of them in a dict object. And also main function is how the application starts. So if you look at line 60, you would see that if name equals main, right? So we're saying let Python start the application from line 60. So when you call line 60, main function gets executed and program starts. Okay, so far so good. This is what we have. Like by the time you run the application calculator, right, it tells you to enter the first value, which randomly select it's 9, and I say multiply by 4. Then it gives you the results, and the program naturally exits. Okay, so what if we want the system whereby you don't want to exit the application, however you don't want the application to exit upon every command. You want the application to just keep running until the user is done. Okay, so let us build that into place. All right, and then figure out a way to say quit this application. Quit this application when you're done. But if you're not, if you're still working on it, okay, continue. All right, so for us to do that, we need to implement like a looping mechanism. Okay, so there are kinds of looping mechanism one can introduce here, but I'm just going to go with the most popular one, the one that runs at infinity until something tells it to stop. Okay, so that's what I'm going to choose first, and then test it out and see how it rolls, and then make a conclusion on this. Okay, so come back here on line 41 and say while true. Okay, and then in Python every indent is a block, so I push this to the next block to say while true, run this application. When you print the results, you say when you print the results, right, and you ask the question, do you want to exit or do you want to continue? Okay, so get input, do want to exit, question, do you want to exit, right? And what you're expecting is a yes or a no. Okay, yes or a no is what we're expecting. So let's do like this and like this. So response, right? So response equals get input, do you want to exit this? So if response equals yes, what break. So line 56 now stops the application from running continuously. Okay, that's what that would do there. So once that breaks, then it means whoever it is has done anything. All right, otherwise just print a new line space. You're going to see how this is going to make sense shortly. Just print a new line space. All right, so that's to give you a chance to start up another section. All right, so very simple. Then let's test this out and see. So I already have everything on the terminal, so I just go Python calculator app.py and I enter, and then it starts all over again from the very first line. It says well true, pass, first asks, which is enter the first value. So let's say 72 and divide by 6. Tells me results 12.0. Then the new construct I just added where it says, do you want to exit? Okay. So if I say no, which is not the answer I'm expecting, it goes back to enter first value. All right. So you can say 34 at 23. All right. So it gives me that and gives me results and asks me again, do you want to exit? All right. If I want to exit, I just do yeah, type Y and it exits. Very simple. So now I can repeat the same system without starting the application all over again all the time until I'm done. Okay. So one of the reasons why we are introducing this question with the exit clause is one, because it's running on a terminal and there is no way for you to more or less like create interactivity like the way it works on the GUI. So we'll get to the GUI aspect and you see why we don't need it on the GUI. But as far as terminal is concerned, we need to know when the user needs to exit the application. Okay, so having done this, now we have a process system whereby we are now asking or saying if you enter first value, right, and then you give your operator command and enter second value, then you see. So how about for people who don't want to type add, subtract, multiply, rem, div, square roots, and cube roots operators, who simply just want to go by the normal, what's it called? Who simply want to go by just the normal symbols, like put in a plus sign, put in a minus sign, like that for every other application. So what we can do for that is increase the keys that calls the function. All right. So one way we can do that is if I say plus addition minus subtraction, then you have asterisk as your multiplication, and then you have this symbol as your division. Okay, if I say this, right, it will give me two things. First, it will repeat the it will do two things actually. It will repeat the number of values I have specified in this particular dict function. Okay, so the best I can do is to avoid repetition, I can create another variable called operators. Okay, and I say these are the operators that I'm expecting. So star hyphen division, star hyphen division, and then I have double star cube roots. Of course, that's how I did cube roots here. If you compare it, oh, oh yeah. So double star. So cube roots is gonna be a problem, but you could say okay, cube roots, and what else? What else do you wanna do? what is it going to do here? We've already covered addition. All right. After addition, we've done subtraction and we've done. So let's see, 1, 2, 3, 4, 5, 6, 7. Let's see, 1, 2, 3, 4, 5, 6, 7. So that's it actually. That's it. So which there's something I'm missing. Yes, remainder, which is symbol of the plus sign. Okay, then to map these to the actions, all right, so we need to create like a mapper, a way to map it to the respective actions. Okay, so if I somehow change this to a dict, so I can say asterisk maps to multiplication, minus maps to asterisk maps to multiplication, asterisk maps to multiplication, minus maps to subtraction, division maps to div, double asterisk maps to sqr square roots, triple asterisk maps to cube, and plus sign maps to add, and percentage, yeah, maps to rem, which is how you calculate remainders. So with this mapping struct information, I can easily, with this mapping struct information, I can easily write like a converter of some sort and say, okay, first argument, action. You know, right now we've said if action in actions, which was really easy. Um, we have to change this construct so that we can accommodate the new symbols to still give us the same result. Okay. Now remember that your target market is always what you consider or factor in. You don't want everybody to remember add, plus, add, sub, multiplication, rem, div, SQR, and CB. You don't want everybody to remember that, and you want them to kind of like always, from whatever it is they're using, to make sense immediately of what it is you're giving to them. In this case, you'll try and tell them to drop your calculator and use this one as your calculator in your office or wherever it is you have a computer. Okay, so to make this make sense to them, you need to bring something that is close, right? That is close to them and won't even give them, so to speak, like so much learning curve before they adapt to the new system. Okay, so that's what this is all about. Otherwise, I don't think we'll just introduce a new system and then leave it at that, and whoever it is motivated enough will be the ones to use it. But in product definitions, you barely do that. But if you do, you have to, do like trainings, sensitizations, importance of why it's going to be there and all. But if you don't have that time, then if you're creating a product, then whatever it is you define with that product, you have to create it similar to what they're currently doing so that migration will be very easy for you. Your target market will be, what's it called? It'll be very easy for your target market to just shift from what they're currently used to the new system you're providing to them with little or no learning curve involved. Okay, so with these operator mappers, right, we're essentially not repeating the function names but repeating the keys and actions, all right, which is what I've done here. So now I need to change this so that action would know how to behave. Okay, so now we're going to have to implement line 50 because we need to accommodate the new operators in town. Okay, so one easy way to accommodate these guys, instead of just having this line, right, because typically it's always very easy for the engineer to use a system because he's designed it, right? But when you're building something for people, you have to also consider their convenience and how they are going to use the system. So in that case, re-implementing this to accommodate the new operators or the new symbols to initiate or trigger an action, and let's put that into consideration as well. So let us say that we have a converter function. So action converter or get action, get action function, get action, right? Okay. So let's say action, which is a string, as we are expecting, should return us a callable. Let me just put any here, but it's actually a callable function. Or it should return a respective string, which in this case will make sense for me. So here I'm saying if action in, right, operators. Okay, then you have operators action return if action in actions return action. Okay, then yeah, yes, this is correct. Otherwise, return none, right? So returns none, it means this becomes optional. So accommodate optional, we say from typing import optional. All right, so this optional, this. So get action would replace what we have here. Action, this, right? And then you say get action, we'll pass action to it, which will give you action. Action, so as not to confuse it, I can overwrite. Okay, let's overwrite, that makes sense. So if action in actions still makes sense, right? If actually in action still makes sense at this point, because whatever it is we are returning still gives us back this guys, the add, subtract, multiply, rem, division, square root, and cube root. Okay, so get action does all of that for us. So you can still say if action in actions, then this still follows suit. Otherwise, else prints invalid action specified. Invalid action specified. Invalid action specified, and after that, what else are we doing? So then you can ask, do you want to exit, or should we run the get action again? It's the question. Invalid action, should we run this get action again is the question. So now I'm going to think it would really be cool if get action has a mind of its own when input is concerned. Okay, so that means for whatever reason, if your action value is not correct, it should prompt you for another action if you still want to make use of the system, as opposed to quitting and coming to a halt. All right, so that said, let's re-implement line 63, which is this get action. Okay, so here again, while true, deliberately. Okay, if actually in operators return, which was tentatively stop, then If action in operators this return would also quit the loop. All right. So otherwise print invalid action. Invalid action specified, and then naturally to come back up. So we need to now take this line 65. You can see everything is making sense now, and put it in line 45. Right, so I cut line 65 and transferred it to line 45 so that any get action sequence, this is going to be autonomous on its own. So if for any reason there's a failure point, like if you miss the operators, it will prompt you to enter the operator again before it finally leaves. So that means this also doesn't make sense. And this also doesn't make sense anymore. See how things are quickly changing, and then I can remove back this duo that I introduced in line 5. Neat. So with this, get action does this and then does the interpretation, and line 65 goes naturally again. So from here, what I'm saying is even cleaner. So let us try that quickly. So Python 3, enter first value 34. Ooh, reference before assignment. Action. Take this out. Good catch. And take this out. All right. So it's autonomous on its own right now with just one job only to get action. Right. Then this. So clear. Start over again. 34. Now let's put an invalid action. Okay. See, so it tells you invalid action specified, enter action. All right. So if I say asterisk, do you see confirmed? And then I can say 45 and press enter. Now when I'm pressing enter, it says result is this. Do you want to exit? And I say no. And it tells me again. Now notice the space between here and here. That is the function of the that should be forward slash and n. So forward slash and n is character for new line space on the terminal. So gives the new terminal and then separates concerns and tells you this is what actually went down. Okay. So from there, enter another value 90 and enter the plus symbol. Notice no error this time around. And 130. It gives you the results. Do you want to quit? No. And then it goes to another branch again. So this time it says enter first value, right? Enter first value is 89. Okay, let's divide. See, correct? Divided by 9. And that gives you 9.888888889. Okay, do I want to quit? No. And then it gets back there. Notice it's still running on the loop until you quit. And then also at any point in time you can Control Z the application and then it suspends. Or maybe Control C would have made sense. So right now we've taken this simple application to the point where we can we can now run it at multiple times until we're tired of the application. Okay. So next on the line for this application is to control or add a bit more dressing to this so that it can make sense to a first timer. Because right now, if you just run it, it just quickly tells you enter first value, enter action, enter second value. To every other person who uses this application will first be taken aback as to what is going on here, So, so on the next next thing on the next approach for or on the next line of action for this application is to put more like an instruction manual or menu, or we need to address these output statements, the print results, invalid actions, and all. So we need to address it so that it can show properly. All right, it can show properly, and it will make more sense on the terminal by the time you show those kind of outputs, and it makes sense. All right, so that's the next thing I'm going to do. So in the next video, I'm going to show you how you can dress this well so that it will make sense to a newbie, which is where that product aspect of the application is coming through. Okay, so while we have the basic going on, right, because this is the basic, this is it. Okay, while we have this going on, we need to dress it to make sense to what's it called, to any user that comes across this application for the first time, anybody who can read and write. Okay, so thank you for staying with me on this. I appreciate you. Have a blessed day.